Okay, well, great. So we'll proceed with the presentation. Thank you for joining us today. Okay, hopefully you've downloaded the presentation as Maria mentioned. This is the course description, and then we have the learning objectives, which you all have received. So for an overview of the presentation, what we're going to do is talk about a little bit of an introduction to give you some background, and then we'll look at principles of fire resistance design, 3 bullet points, and then we'll get into interior wood finishes, which sometimes you may get a question from an architect regarding the use of wood as a finish material in a building. We'll look at fire safety during construction and design examples. And if you've downloaded the handout, you'll notice that there are quite a bit of slides. We may skip through really quickly through the interior wood finishes and fire safety design construction, just to touch on that if we're running out of time, and really get into the design examples, because I'm sure some of you in the audience really want to look at the number crunching aspect of what it takes to provide fire resistance design for wood construction. And let's move on. So just a little background on related to fire protection. Related to the IBC, this presentation is based on the 2015 IBC. And what the building code does, it pretty much controls the size of the building, and it regulates the type of construction that is being used, or the type of materials that are being used in the building, whether it be combustible or non-combustible. And then it stipulates, it's prescriptive in the fire resistance requirements. One thing we should note is that they use the language of combustibility and fire resistance throughout the code, and they are 2 separate characteristics. Something could be highly combustible or non-combustible, but have a low fire resistance. For example, if you have light cold formed steel, that's a non-combustible material, but when it's exposed to fire, it will decay, degrade. Whereas you could have something, say, wood construction, heavy timber construction, that's combustible, but yet when it's exposed to fire, it does have a amount of fire resistance, more so than perhaps a cold formed steel being exposed without any fire protection. So just know the 2 characteristics, combustibility and fire resistance, are 2 separate characteristics in the code, and they're both covered in the code. Now, I mentioned that the code does control the size of the building, and there are tabulated values within the code, which we'll go throughout this presentation, showing the baseline for the square footage of a building. And then there are some increases beyond that related to frontage, if there's area around the building, and also if there are sprinklers. And then beyond that, there are special provisions in section 510 of the code. And that's where we get into one of the biggest uses for that section have to do with podium type construction, where the code treats the upper portion of the structure as a separate building for figuring out the area, the number of stories, from the lowest portion of the structure. So you would have a concrete podium, there'd be a horizontal separation between the 2 buildings, say a 3-hour horizontal separation, and that's oftentimes why it's concrete. And then above that you could have wood structure. So that's where in chapter 510 there are special provisions. There are all other special provisions in there related to heavy timber construction, but allowing an architect to increase the size of the building using that aspect, because they treat it as 2 different buildings. Except for when we talk about the overall height of the building. The overall height is from the grade plane all the way up to the average roof height. So why is this important, and why are we talking about area? Well, when the architect gets a project, they want to understand, 1, what is the occupancy, and what is the required square footage that we're going to need to make this a project that is successful from a budget standpoint, from an occupancy standpoint. So they utilize these tables within the code to determine what size of building can we do, optimizing the size of building, understanding fire resistance requirements, and understanding the type of construction, and we'll look at that. Now, when you think about it, many of us, we get the architect goes through these exercises in determining the size of the building and the type of construction. But why aren't our engineers more involved in that process of determining the type of construction? When we're the ones that are designing the structure, why aren't we more involved with that decision making and helping determine, should it be categorized as type 1? Should it be categorized as type 5? Should we be using wood, or should we be using steel or concrete?